Good morning to Teacher Betty and my fellow friends. We are from Group 2, which is Evan, DEYLEENA, DOREENA, Anatalia, and EMBER. Will represent question 3 from extensive practice in Chapter 8.
For question A, the situation can be expressed as t equal to negative 6.5 divided with 1000 multiplied with x plus 30.
So for question B, it has to verify our answer in A. We got negative 6.5 times 1000 from the information given, where it said that the temperature decreases 6.5 degrees Celsius every 1000 meter. But we add 30 because the temperature at sea level is 30 degrees Celsius. For question C, this is the graph that shows the relationship between x and t. For question D, the reasonable range for the function tx is more or equal to 4 degrees Celsius and less or equal to 30 degrees Celsius. This is the reasonable range for the function tx because from the graph, when x is 4000, t is 4. We choose 4000 as the highest altitude because the maximum height of Mount Kinabalu is 4095 meters. Thus, T is at least 4 degrees Celsius or higher. And from the information, it said that at altitude 0, T is 30 degree, which means T is not more than 30 degrees Celsius. For question E, we need to find the gradient of the graph by using the formula m equal to y over x. We need to take 2 points from the graph and divide with the x between them. For example, 30 minus with 17 and divide with the 2000, which we get 6.5 exponent negative 3. Convert this to decimal point and we get 0.0065. This means that the temperature decreases 0.0065 degrees Celsius every 1 meter of the altitude. For question F, it asks for the y-intercept from the graph drawn. So from the graph, the y-intercept is 30, which means that the temperature at 0 altitude, or sea level, is 30 degrees Celsius.
G. Yes, it is reasonable to assume that temperature always decreases at a linear rate as altitude increases in the troposphere, because the relation between T and X is a linear function.